Hi everybody, this is Shivkumar. Today we are going to discuss about equations of motion. So these equations of motions, where do we use? We are going to use this equation when an object is moving in a constant acceleration. Okay, so those equations are v is equals to u plus at, s is equals to ut plus half a t square, v square minus u square is equals to 2as, where v is the final velocity, u is initial velocity, a is acceleration and t is time, s is displacement. So these three equations we are going to derive now. Okay, so first of all, where do we use these equations of motion? So in constant acceleration, when we have constant acceleration, when constant or uniform acceleration, when we are having uniform acceleration, then we are going to use these three equations. Okay, so in order to get that, first we need to know what is acceleration. So we know that acceleration is nothing but the rate of change of velocity. So the acceleration A, we are denoting it with A. So acceleration A is equals to rate of change of velocity. That means change in velocity by time taken. Okay, so we can take change. So we can take an object. Let's take an example. An object is moving with certain velocity. Okay, so let's take a car. Okay, a car is moving with certain velocity, but we are not considering. So at this point, the velocity of this car is u meter per second. After some time t, it went to here. Okay, so this velocity is v meter per second. Okay, so from here to here, the time taken is t, and this is the distance between this position and this position is s. We call that as a displacement. Okay, so this is my final velocity and this is my initial velocity of an object when we are considering. Okay, so when I am considering at this point, I am taking time t is equals to 0. Okay, from here I am considering time is equals to 0, and to reach this point we are taking time t is equals to t. Okay, so here what happens? Change in velocity. Change in velocity means this is final velocity minus initial velocity. Change means final minus initial. So final velocity minus initial velocity by time taken, that is equals to acceleration. Okay, when we are taking constant acceleration means what happens? The change in velocity should be equal in every equal interval of times. Okay, so here the acceleration A is equals to v minus u by t. By transposing this, we can get at is equals to v minus u, v is equals to u plus at. Okay, so this is my first equations of motion. So v is equals to u plus at. Okay, coming to the second equation, how do we derive it? By taking v, s is the displacement, right? So we know that. So second equation, we know that the average velocity, average velocity is equals to displacement by time taken. We know that the definition of the average velocity is the ratio of displacement to the time taken, or the rate of change of displacement. Here, that is average velocity. So coming to this, here we are having how many velocities? We are having two velocities. That is final velocity and initial velocity. So by taking these two values, we can take an average. That is equals to v average is equals to final velocity, initial velocity by 2. Okay. sum of the velocities by number of velocities is my average velocity. So V average is equals to V plus U by 2 and V average is equals to S by T. Okay, so we can take this equation 1, equation 2. Both are equal. Why? Because V average. Here we are taking V average and here also we are taking V average. So S by T is equals to V plus U by 2. Right? So here what happens? Here we already got the value of V. What is that? V is equals to U plus AT. Now substitute that V in this. So S by T is equals to V. In the place of V, we need to substitute U plus AT. So U plus AT plus U by 2. Okay, so I would like to take this T, I would like to transpose this T from this side to this side. Then what happens? This will become, here U is there, U is there. So 2U plus AT by 2 and taking this T. So T. So here what happens? This will be equals to 2UT by 2 plus 8t square by 2. This is equals to S. S is displacement. So here what happens? 2 will get cancelled out. So S is equals to ut plus half at square. So here we got the displacement value, that is equals to S is equals to ut plus half at square. Here also we are having S is equals to ut plus half at square. This is my second equation of the motion. So coming to the third equation. So let us take this equation S by T. Okay. So here what happens? S by T is there. So third equation I am writing here. So S by T is equals to V plus U by 2. That will be equals to S by T V plus U by 2. Right. So taking this T, S is equals to take. So V plus U by 2 into T I am taking. Right. So in the place of T, so let us take here the acceleration definition. A is equals to, I would like to change this equation. T is equals to V minus U by A. Can you write like that? Yes, we can write. So T is equals to V minus U by A. Now I would like to substitute in the value of this. So S is equals to V plus U by 2 into V minus U by A. So here what happens? Here this V plus U times V minus U by 2A. So it is looking like A square minus B square. That is equals to A plus B times A minus B. Okay. A square minus B square is equals to A plus B times A minus B. Okay. So similarly there also we are having V plus U times V minus U. That means we are going to get V square minus U square by 2 times of A is equals to S. So I would like to take this 2A from this side to this side, then V square minus U square is equals to 2AS. So we got the formula, we got the equation of third equation of the motion, that is equals to V square minus U square is equals to 2AS. Okay, so we will understand this by doing some examples. Okay, let us do some examples. So when an object or a car, okay, a car is moving with the initial velocity 10 meter per second. An object, a car is moving with 10 meter per second, making the constant acceleration of 2 meters per second square. Okay, so then find the velocity at time t is equals to 3 seconds. So which formula should we have to use? We are having three formulas. V is equals to U plus AT, S is equals to UT plus half AT square, V square minus U square is equals to 2AS. So here we want the final velocity. Okay, so we need to find out V. So V is equals to U plus AT. So we need to find out the U value. So we need to find out the V value. So U is equals to 10 meter per second plus acceleration is equals to 2 and time t is equals to 3. So the velocity after 3 seconds will be equals to 10 plus 6, that is equals to 16 meter per second. Okay, like that we need to find out. So So we can also find out that how much displacement it took after 3 seconds. So from here to here it went somewhere. Okay. So we need to find out how much displacement it took. So by using, we can take this formula or this formula. We can use any formula. So here I would like to use S is equals to ut plus half a t square. So S is my displacement, u is equals to 10 meter per second, and time is equals to 3 plus half a. Acceleration is equals to 2 and time is equals to 3 square. That is equals to 3 into 3. So 2 will get cancelled out. Then it should be equals to 30 plus 9, 39 meters. So then what happens? So when an object is having initial velocity 10 meter per second and the acceleration is having 2 meter per second square, after 3 seconds the object will move to 39 meters. Okay, like that we need to do. So we have taken this formula, right? So now we would like to take another formula that is equals to v square minus u square is equals to 2as formula. Okay, so what we want? We want S. So S is nothing but the displacement. So S is equals to v square minus u square by 2a. So 16 square is equals to 256 minus u square. U square is equals to 10. 10 square is equals to 100 by 2 times of a. 2 into a. A is how much? 2. 2 to the 4. That is equals to here what we are going to get 256 minus 100. That is equals to 156 by 4. By doing this, we are going to get 39 meters. So we can use any two formulas. So a car is moving with the initial velocity initial velocity 20 meters per second after 4 seconds its velocity became 15 meters per second. Then find the acceleration. Okay, so which formula should we have to use? We have to use v is equals to u plus at, or v square minus u square is equals to 2as. Should we have to use this? No. Why? Because here the displacement is not given in the question, but for this, for the given data, we need to use v is equals to u plus at. So v is equals to u plus at. So acceleration is equals to v minus u by t. So what is the final velocity? Here I got 50 minus initial velocity 20 by time taken is 4 seconds. That will be equals to 30 by 4 meter per second square. That is also equals to 12. That is also equals to 15 by 2 meter per second square. This is also equals to 7.5 meter per second square. So here I got the acceleration. Okay, so we'll do another example. Is moving with the initial velocity of 20 meter per second. Okay, so by applying the brakes, so it stopped. The car stopped after 2 seconds. After 5 seconds. Then we need to find the acceleration. What is acceleration? What is the safest distance? What is the safest distance? That is nothing but the displacement. Okay, so here the car is moving with 20 meter per second and brakes are applied. After 5 seconds, the car became stopped. The car was stopped. So then what happens here? U is equals to 20 meter per second time is equals to 5 seconds and v is equals to 0. Okay, so we need to find out the acceleration and we need to find out the displacement, safest distance. So here we are having u is equals to 20 meter per second, t is equals to 5 seconds, v is equals to 0. So we need to find out the deceleration. A is equals to v minus u by t. Right? So what is v? V is final velocity. That is equals to 0 minus u. U is equals to 20 meter per second and time is equals to 5. Then this will be equals to minus 4 meter per second square. So here what happening? The change in velocity comes into negative. Why? Because the final velocity is 0 here. Okay, so the velocity is decreasing. Okay, so this is called retardation or deacceleration. Okay, so the deacceleration is equals to 4 meter per second square. And here they asked the safest distance. So safest distance is equals to s is equals to ut plus half a t square. We can use this formula or s is equals to v square minus u square by 2 times of a. Okay, so generally we will use this formula to get easy answer. Okay, so v square is equals to 0 minus u square. U is how much? 20. So 20 into 20 by 2 times of acceleration. Acceleration is how much? Minus 4. So minus into 4. Minus will get cancelled out. 2 ones, 2 tens, 4 ones, 4 fives. So the answer will be equals to 50 meters. So when a car is moving with 20 meters per second, so the brakes are applied. After 5 seconds, it will reach 50 meters when the deceleration is 4 meter per second square. We can also call this 4 meter per second minus 4 meter per second square as acceleration. Okay.